Well, we've finally done it. We've made it all the way from atoms up to biomes, which together make the biosphere, which is all there is for biology. So we really have done a great job of following along on the hierarchy of life, the hierarchy that talks about the building up of life from atoms through building blocks, through cells, through organisms, and all the way up to ecosystems. Now it's time to look back at what we've learned and how we have learned it, how we have put this together in our mind. So in our first few lectures, we discussed something called Uno's cube, and it had three orthogonal hierarchies. The first hierarchy was the Linnaean Taxonomy, which is just what you learn about how to break things into mammals and reptiles and animals and plants and all those different classes, phyla, etc. So we learned that that is a great hierarchy that includes every living thing on this planet, and each one, of course, has its own Latin binomial name. Then we learned about how there's another hierarchy, the hierarchy that we based our class on, that is the hierarchy of levels of organization according to the Uno cube. But I like to think of it as the hierarchy that builds up life from the atoms all the way up to the biosphere. And of course, at the top of this cube, something that we haven't really focused on is the key concepts in biology, things like how matter and energy are transmitted, and evolution and ecology, and sort of just major classes of biology. Now that top level is what a lot of textbooks use to organize their facts. So you can be keeping that one in mind too, and as you think back on what we've learned. But we really focused in on the hierarchy that is building up life, and we had 10 lectures right off the bat of this type that led us all the way up to organs. And then once we hit organs, we had another 11 lectures that discussed organs and brought us all the way up to ecosystems, biomes, and the biosphere. So that was a total of 21 lectures out of these past 38 that really focus in on this special kind of hierarchy. Now, what else did we have besides those 21 lectures? Well, we talked a little bit about energy flow, homeostasis. We also looked at reproduction and some general knowledge things like thermodynamics that help us as we learn about biology. Where are we at now? What do we have left to learn? Well, we just have sort of a final lecture on how do we trust what we know. But before we go on to our very final lecture, let's have a little bit of a mental activity that you can do on your own. You can try to come up with ways to organize the things that you've learned in some kind of a framework. We have Uno's cube, of course, and that's a great one to use to organize your thoughts. But can you think of another way to organize the study of life? And if you think of another way, writing out all the different lectures that we've learned about and organizing them in some kind of a structure, how does your different structure compare to Uno's cube, and how does it organize the data? The advantage of Uno's cube, of course, is that it allows you to kind of use an X, Y, and Z approach, just like I talked about in my research. If you study a certain type of organism, like a fruit fly, and if you study a certain level of what builds up life, like a molecular machine, and if you study it in a certain category, like in the physics of biology, that's a certain category of organizing principles, then you can find your X, Y, and Z and find the location in the big world of biology that you are studying or that you are learning. So that's one advantage of Gordon Uno's cube. But your system that you may have thought of may have your own personal advantage. Now, a little story to illustrate how wildly different ways of organizing things can be helpful is the periodic table. Now, we're all familiar with the periodic table. We see it on people's T-shirts, and it has a certain shape to it. And if you look carefully, you'll see that there are every different kind of element that's in the universe listed in that table. Now, this table was developed by a Russian man named Dmitry Mendeleev, and he saw that there was a repeating pattern in the elements as the elements got heavier. Now, at the time that he developed this table, there were many missing slots in this repeating pattern, so he wisely just kind of inserted a blank card, assuming that at some point we would find that element. And the result, which of course the Russians call the Mendeleev table and we call the periodic table, is a guided discovery that helps you learn what you want to learn. So it guides you as you're trying to understand the different elements. Now there are other ways to organize this pattern. If you get onto the internet and look for alternate periodic table images, you can find ones that look wild and are in 3 dimensions. And one of my favorites kind of looks like the Starship Enterprise and starts in the very center of the round disk on the Enterprise and winds its way around in a spiral as each of the elements gets heavier. And it organizes it kind of more like a pie graph with the different categories of elements as different slices of the pie. So you can find out some other ways that things are organized both in chemistry and the periodic table and in biology, and try to, at this point, since you've been through all of these lectures, organize what you've learned about the living world. And if you're going a little deeper, now would be a great time to read several branches that we have not covered in the BioBook. For example, how are the different groups of animals related to each other and what distinguishes them? And what other major groups of organisms exist on Earth? These branches obviously cover a huge amount of material, but now you have the tools that you can understand them, and as you go through each of the leaves and take the little reading quizzes, you'll see how much you've actually learned in this class.